Hello and welcome to our talk on variation in representation. Today I'm going to be talking you through some of the ways that we show a variety of representations in our maths lessons to enable children to learn a new concept or idea in maths. Now, when I was at school, variation basically meant that the numbers on the sheet changed. So you had a range of questions to answer and it was just different numbers each time. Now, at Dunkirk, we believe that maths is about learning and not performing. We want children to be able to apply what they have learned to different situations. We want them to be able to problem solve, to reason. So whilst that approach can have some merit in lessons, we believe that we want our children to learn and every second is precious. So because of that, like we mentioned in the parent workshop, we are moving on to a teaching for mastery approach. Now you can see here that the variety of representations and structures plays a crucial part in teaching for mastery. And this is because it allows children to access a wider variety of maths. It allows them to create patterns and to see patterns in the maths that they are learning. And therefore it allows them to make connections to other mathematical concepts. So for example, they're making the connection that multiplication is the same as repeated addition. Now, one term that you may hear used is the concrete, pictorial and abstract approach, and you will hear this a lot, and that is simply because it is such an effective approach that leads to really deep understanding in all of our pupils. It isn't a new approach, it's been around for many years. It was developed by the psychologist Jerome Bruner, and he is famous for his research in the 60s looking at how children develop cognitively. Now, he basically said that pupils will learn new ideas with actual physical objects. They then draw diagrams or pictures which show their thinking, and then finally they will be able to access the abstract form of that new idea. So for example, if in a power maths lesson the children have to count blocks that have been spilled on the floor, we actually spill blocks on the floor and get the children to work in teams to figure out the best way to do this. Now, it's really important that they have access to the real blocks because it suddenly makes it a real life situation. But also it enables the children to count accurately, to group in different ways, to order the blocks and then to partition, and in this example to partition into tens and ones to allow them to count a lot more efficiently. So here are some more concrete examples from actual lessons. So we've got children using the place value counters at the top. We then move on to a bead string. We have got base 10 being used for repeated subtraction and base 10 on a place value chart. Then down at the bottom we've got an example of a child using blocks to create a block diagram. In the middle here we've got an example of Lego being used to create an array to help support a child's understanding of multiplication. And then at the bottom right we have a 10 frame with some magnets on it. Now, once the children are secure in the concrete example of the concept, they then move on to the pictorial. So as you can see, this is the exact same thing that they've just been learning. However, instead of it being actual blocks that they're grouping into tens to efficiently count, they now have a picture where they can group the number of stars and then they can represent that on a number line, showing that they are still counting in tens and it's an efficient method rather than counting one each time. Then finally, the children move on to the abstract form. So in this case, we're looking at a number line with some of the numbers missing or a number tracker. Now, in a lesson, we will use lots of different representations, and some of the ones that I'm going to talk to you today are the most common ones that we use. So a 10 frame is key in helping children understand that numbers are composed of tens and ones. It also helps the children identify how many numbers are how many numbers of the objects are there. So for example, you can see with the blue magnets there are 9, with the white magnets there are 8. Now for children, when they first begin to do this, they would have to count how many magnets there are. However, it's far more efficient to develop the strategy knowing that, for example, that's a 10 frame, so if there's one missing, it must be 9. We don't need to count. And the more we get children to do this, the more they automatically know that there is a 9 and an 8 there. And also, more importantly, children love 10 frames. They can be done in a lot of different ways, using stickers, sweets, colourful counters, fuzzy pom-poms. I mean, this example is a baking tray with magnets on it. However, you can utilise a whole range of different objects to support the learning in a 10 frame. And the more fun it is, the more children are going to engage with it. We also use number lines quite regularly in our lessons. Now, number lines are really important because they help children to add and subtract efficiently. So one of the things we often see when children start adding is if they were adding 3 and 4, they would use their fingers, they would count 3 fingers, then they would count 4 fingers, then they would have to go back to 0 and count their fingers on again to 7 to find the total. Using a number line helps children have that light bulb moment that they can actually start at 3 and they can miss out a complete step. So whilst counting on the fingers is an effective strategy and it is an accurate strategy, it's time consuming, so it's not efficient, and also it can leave open a lot of opportunities for error. Using the number line, starting at 3 and counting on 4, the children can quickly get to the right answer. Now, step on from this is when children are using larger numbers. So for example, if it was 23 and 54, children will begin to realise that actually it's more efficient to start at 54 and count on 23 by partitioning the 23 into 10s and 1s. Now, once children are secure in using a number line in this way, it means that we can begin to teach them how to skip count. Now, all skip count means is that they don't say all of the numbers. So if they're counting in 3s, they wouldn't land on the 1, 2, 4, 5, 7, 8, 10 or 11. They would only land on 0, 3, 6, 9, 12. And this automatically allows children to join the concepts of repeated addition and multiplication as the same thing. So 3 add 3 add 3 is the exact same as 3 times 4, which makes learning the concept of multiplication quite a lot easier. In our lessons, we also encourage children to use the place value chart. Now, place value charts help children to understand the value of the digits in a number. So if children are given the number 8,980, they quite often, if they haven't seen it represented in this way, don't really have an idea of what the 8980 mean. So it's really important that we show them on a place value chart, explaining, for example, that a 10 is simply 10 ones, or 100 is simply 10 tens. And by viewing it in this way, it really helps children grasp the concept of what is actually going on in those digits. Now, this is really important when it comes to exchanging, because if children only ever see the abstract concept of the addition where you have to exchange, they have no idea what those ones mean. It's quite easy to think that, yes, children have got the concept of ones and tens, so we don't need to show them a representation like this in year 4 or year 5. However, they need to be able to see that the ones underneath simply mean that, for example, you have too many ones in the one column, so we're going to have to exchange 10 ones for 1 10. And all that number down there means is that you have exchanged for 1 10. Now, another representation that we use quite often in class is the part-whole model, and this is sometimes referred to as the cherry model purely because it looks like a cherry. Now, this is really important because it introduces children to the idea that a number can be a whole or it can be made up of different parts. Quite often we find that children see 33 as 33. It can't be broken up into any parts, and this can restrict them when they're coming to do things like addition. So if you consider the problem 8 plus 5, for many children they would have to count on 5 on their fingers. However, it's a much more efficient strategy to partition the 5 into a 2 and a 3 into 2 parts, add on the 2 first to make the next 10, and then add on the 3. They are calculations that the children find a lot easier than 8 plus 5, and so they will inevitably be more successful. Now, this is also important when it comes to situations like missing number problems. Children of all ages really struggle with that kind of calculation. However, as soon as they represent it in a part-whole model, they understand what it is that they've got to figure out, and they can either do this using column subtraction or by using manipulatives to help further their understanding. Now, a step on from this is the bar model. Now, bar models and part-whole models are very similar. The only difference is that the bar model allows you to represent the value of the digit. So, for example, 30 is a much smaller value than 60. So in the bar model, you can see that the 30 is a smaller block than the 60. Now, bar models can be used to represent addition, subtraction, multiplication and division really well. However, they're also really useful for when children move further up through school and they're having to begin to convert fractions into decimals and percentages, and when they're beginning to add and subtract fractions, for example. You can see that for some children, a third plus a half is quite a challenging concept, but as soon as you represent it in a bar model, it suddenly becomes a lot easier for them to see and get the correct answer. Now, these are really crucial when it comes to word problems. We give the children quite sophisticated and challenging word problems, and they can really struggle with them because there's a lot of information there. However, we encourage the children to represent that information in the form of a bar model, and suddenly it becomes really easy for them to see what exactly it is that they've got to do to solve the problem. And finally, here are some more complicated examples of word problems that children have to solve. So we've got some simpler ones that Year 2 may have to work on down at the bottom. However, we then go into some quite complicated word problems about bottles of milk for sale, and the bar model really helps children figure out what it is that they've got to work out. Now, these are just a few of the representations that we use on a daily basis. If you want any help with these and how you can use them to help support your child's individual needs, please talk to your class teacher. They'll be more than happy to help. And if you have any further information or any other vocabulary that you would like me to go through, please let me know and I can add it into one of my future workshops. Thank you very much.